Okay, so let's start with the demand function for two products. We know that Kx is 2 minus 2px plus py, and for Ky is 6 minus 2px minus 3py. Now we're gonna calculate partial derivative. For Kx is 2 minus 2px plus py. So, dou Kx per dou px is minus 2. This means when the price of x is increases, the demand for x decreases by 2 units. Next, for py, dou Kx per dou py is plus 1. This means when the price of y increases, the demand for x increases by 1 unit. Next is for Ky, 6 minus 2px minus 3py. So, dou Ky per dou px is minus 2. And for the dou Ky per dou py is minus 3. This means when the price of x increases, the demand for y decreases by 2 units. And this is mean when the price of y increases, the demand for y decreases by 3 units. And now let's analyze the cross price effect. This is show positive effect and this is show negative effect. Because one cross partial is positive and the other is negative, the effect is not consistent. So the product are neither substitutes nor complement.
I will now present how to find the critical point and determine whether it is a relative maximum, minimum, or saddle point. So the function is z equal 3 plus 2x plus 2y min 2x squared min 2xy min y squared. For the first, take the partial derivative dou z per dou x equal 2 min 4x min 2y dou z per dou y equal 2 min 2x min 2y. The second step, find critical point, set gradient to 0. So now we eliminate one variable, subtract equate 2 from equate 1. So min 2x equal no x no. Now we substitute the x to Now we found the critical point x 0 equal 0 and y equal 1. Next, we compute the second order partial derivative. So, dou squared z per dou x squared is mean 4 and dou square dou z per dou y square is equal mean 2 and dou square z per dou x y is mean 2. Now from the Hessian matrix. Mean 4, mean 2, mean 2, mean 2. So we get mean 4. We get the determinant of the Hessian is 4. So we get the determinant Hessian is 4 greater than 0. And we conclude that the function has a relative maximum. Done.
First, we are given the demand functions as px equal 12 minus kx, py equal 13 minus ky, and the total cost is 3kx qy. And then first step is we want to find the revenue. Revenue function is r equal px kx plus py ky, and then we want to substitute the price functions into the revenue. So r equal px, we get 12 minus kx, 12 minus kx times qx, and then plus py, we get 13 minus ky times ky. So we get revenue 12 qx minus qx square plus 13 ky minus ky square minus 3 kx key. Yeah, I forgot to put the total cost in here. So minus 3 kx ky. Now we can minus and plus the functions. We get 12 kx plus 13 ky minus kx square minus ky square minus 3 kx ky. I'm sorry because I made a mistake. The formula should be V equal total revenue minus total cost. Next, find the first partial derivative. Dou V per dou kx equal 12 minus 2kx minus 3ky. And then dou V per dou ky equal 13 minus 2ky minus 3kx. Step 3, eliminate. Minus 2kx minus 3ky plus 12 equal 0. And then minus 3kx minus 2ky plus 13 equal 0. And then times 2 and then times 3 equal minus 4kx minus 6ky plus 24 equal 0. Minus 9kx minus 6ky plus 39 equal 0. Minus equal 5kx minus 15 equal 0. So we get the kx equal 3. After we get the kx, we should substitute to find the ky. Minus 2 times 3 because we change the kx to 3 minus 3ky equal 0. 3ky equal 6, so we get the ky equal 2. After we get the kx and ky, we should substitute to px and py. First, px equal 12 minus, we get kx equal 3, so we change the kx to 3 equal 9. And then py equal 13 minus qy, we change to 2 equal 11. Now we check the nature of the critical points using second derivative. Dou square v per dou kx square equal minus 2. And then dou square v per dou ky square equal minus 2. And then dou square v per dou kx ky equal minus 3. Next step is find the Hessian matrix. Hessians equal minus 2, minus 3, minus 3, minus 2. Then we compute the determinant of these Hessians. determinant Hessians minus 2 times minus 2 minus 3 squared equal 4 minus 9 equal minus 5. Since the determinant Hessian is negative, the Hessian is indefinite, which means the critical point is a saddle point. Final steps. After we get Kx equal 3 and Ky equal 2, we should substitute the Qx and Ky to these functions. So, we get V max equal 12 times 3 plus 13 times 2 minus 3 square minus 2 square minus 3 times 3 times 2 equal 31. So this is the final V max.
Okay, so the shirt manufacturer has the following total revenue and total cost function, where the Q is represent the number of shirts produced per month, and the company is currently producing the shirts. The quantity of shirts is 2,000, and the questions are: is 2,000 shirts the profit maximizing quantity of production? If so, why? And if not, what should the company do to increase its profit? Okay, to determine if the 2,000 shirts is the profit maximizing quantity, we need to find the quantity which is Q that maximizes profit. So we have to find the profit. As phi of Q is total revenue of Q minus total cost of Q. We substitute the value. Phi of Q minus 0.003 Q squared plus 20Q minus 0.002 Q squared minus 1.5Q plus 3,000. Okay, so we simplify the equation. 0.003 Q squared plus 20Q minus 0.002 squared minus times minus is plus 1.5Q and minus times plus it's minus 3,000, and then the minus 0.003 Q squared, it can minus 0.002 Q squared, so it's 0.005 Q squared plus 20Q plus 1.5Q, it's 21.5Q minus 3,000, so it's the pi of Q. And the quadratic function, since the coefficient of Q squared is minus, and the parabola opens downward like this, so the maximum point occurs at the vertex of the parabola, and the formula to find the vertex of the parabola is Q max is minus B over 2A. So it's, let's substitute the value. the minus b is 21.5, and the a is minus 0.005. So it's minus 21.5 over 2 times minus 0.005. So it's minus 21.5 over minus 0.01. So it's 2,150. So the quantity that maximizing the profit is 2,150, not 2,000 shirts. So 2,000 shirts is not that profit maximizing quantity, and the company should increase production from 2,000 to 2,150 to maximize profit. Okay, next question. Okay, the next question is what is the profit at Q equals 2,000? So to find the profit when 2,000 shirts are produced, we have to substitute the Q equals 2,000 into a profit function. So pi of 2,000 equals minus 0.05 times 2,000 squared plus 21.5 times 2,000 minus 3,000. We calculate the function. It's 2,000 squared is 4 million. So 4 million times 0.005, it's minus 20,000, and 21.5 times 2,000 is 43,000 minus 3,000. So pi of 2,000 is minus 20,000 plus 43,000 is 23,000, and 23,000 minus 3,000 is 20,000. So the profit when 2,000 shirts are produced is 20,000. The last question, what is the maximum amount of profit the company can earn? So the maximum profit occurs when quantity of shirts is 2,150. So we substitute the 2,150 into profit function. So it's 5,100 and of 2,001 is minus 0.005 times 2,150 squared plus 21.5 21.5 times 2,150 minus 3,000. Let's calculate the function. So 2,150 squared is 4,622,500 times the minus 0.005 is minus 23,112.5 times 21.5 times 2,150 is 46,225 minus 3,000. It's 2,112.5. So the maximum profit that company can earn when producing 2,150 shirts is to 20,112.5. Thank you for watching.
Okay, so here I will answer the question of chapter 19, number 27. Okay, the question is, if the utility function is u equals 3xy minus x squared minus y squared, and the budget equation is x plus y equals 12, values of x and y that maximize u. Okay, the answer, the first, write down the utility function and the constraint. The utility function is u equals 3x y minus x squared minus y squared. The constraint is x plus y equals 12. Okay, next, now let's build the Lagrange function. We do this by taking the utility function and adding lambda for the constraint. Lambda x y Lagrange. X is 3x y minus x squared minus y squared plus lambda 12 minus x minus y. Next, we take the partial derivative with respect to x, y, and lambda. First, dou u per dou x equals 3y minus 2x minus lambda is 0. This is the equation 1. Okay, 2 dou per dou y is 3x per minus 2 y minus lambda is 0. This is equation 2. Dou u per dou lambda, it's 12 minus x minus y equals 0. This is the equation 3. Eliminate lambda from equation 1 and 2. Equation 1 is 2x plus 3y minus lambda, it's 0, and 3x minus 2y minus lambda, it's 0. Minus 5x plus 2 plus 5y, it's 0. This is the equation 4. Eliminated equation 3 times 5 and 4 is minus 5x plus 5y equals 0, and minus 5x minus 5y, it's minus 60, and then 10y, it's 60, and y is 6. Okay, now substitute into the constraint. Is minus x minus y equals minus 12. Minus x minus 6 is minus 12. Okay. Is x plus y is 12. X plus 6 is 12. And x is 6. Find the lambda. Look into equation 1. 3y minus 2x minus lambda. It's 0. 3 half minus lambda is 0, and lambda it's 6. And then next, take second derivative. Dou squared u per dou x squared is minus 2. Next, dou squared u per dou y u is minus 2, and dou square u per dou x dou y dou y is 3, and dou squared u per dou y dou x is 3. We use Hessian matrix is 0, 1, 1, 1 minus 2, minus 2, 1 minus 2, minus 2. Okay. Yes. 0, 1, 1, 1 minus 2, minus 2. Okay. Find the determinant. 0 plus minus 2 plus minus 2 minus 2 minus 0 minus 2. Final is 0. Find the u max. U max is 3, 6, 6 minus 6,
squared minus 6 squared. Final answer is 36.